Today we're going to be talking about identity and inverse matrices. Identity and inverse matrices are a very useful tool for solving systems of equations. First of all, let's take a look and see what identity matrices are. I have some examples. If you noticed on a 2 by 2 identity matrix, the diagonal that runs from left to right downward is made up of ones, and the diagonal running from left to right upward is made up of zeros. Next to it, I have a 3 by 3 matrix. We have the same thing. The diagonal running from left to right downward is made up of ones, and everything else is made up of zeros. So those are identity matrices. Same idea as having, if you had an identity matrix, think of it as having a 1 in front of an x. That's same thing as having just x. So that's one way to think of it. An inverse matrix. That's a matrix you can multiply by to get an identity matrix. Usually we try to get x or y alone in an equation. This is what we're trying to do. We're basically trying to get a matrices made up of variables alone so that we can actually find out what x and y are equal to. So an inverse matrix is a matrix you can multiply by to get an identity matrix. The symbol for the inverse of matrix A is A with an exponent of -1, and we just basically say that's the inverse of matrix A. So let's go on to some examples. We want to decide whether the following matrices are inverses of each other. So basically what we're going to do, what we're hoping for is if they are inverses of one another, we're going to get an identity matrix, which I'm drawing in. This is what we should get as a result. But let's see what happens if we multiply these together. So we're going back to matrix multiplication. So we're going to take 3275 and multiply it by 5, -2, 2, 1. So let's do this. And we're going to say 3 times 5 plus 2 times 2. We're taking the first row times the first column, and we get 15 plus 4, which would mean our first entry in the resulting matrix is a 19. Now already this isn't working out because the first entry should be a 1 if it was an identity matrix. So right off we can say these matrices are not inverses. So we can just write that right down. Let me erase this. These are not inverses. Okay, so that was easy enough. We saw that right off. Let's take a look at these next two matrices and see if these are inverses of each other. We have 9, -2, 5, -1, multiplied by -1, 2, and -5, 9. So let's try that. First row times first column, we're going to say 9 times -1 plus -2 times -5. So we have -9 plus 10. The result is 1. Okay, so that is the very first entry that we would find in an identity matrix, so we do want to continue. Let's do the next one. Let's take the second row times the first column. So we have 5 times -1 plus -1 times -5. So we get -5 plus +5, and that gives us 0. Okay, so things are looking good. That is what we would have in an identity matrix. So let's continue. We have first row times second column, so we have 9 times 2 plus -2 times 9. We have 8, so which gives us 18 minus 18 gives us 0. That is what we would normally have in an identity matrix. This is looking good so far. So let's now do the last row times the last column. We have 5 times -1 plus, 5 times 2. Let me go back. Change that. I was looking at the wrong entry. So 5 times 2 plus -1 times 9. So we have 10 minus 9, which gives us 1. And sure enough, we do get an identity matrices, so these two matrices are inverses. So we'll say yes, they are inverses. Great. So now that we've established that, let's move on to our next problem. We'd like to be able to figure out how to find the inverse of a matrix. And I'm going to show you for 2 by 2 matrices. If A is a 2 by 2 matrix with entries A, B, C, D, then the inverse of matrix A is found by taking 1 divided by the determinant of matrix A times what we're going to do basically is switch the order that the A, B, C, and D are in and change the sign of some of them. We're going to be taking the first entry to be D, the second entry going across to be -B. In the second row, we'll take the first entry to be -C and the second entry to be A. So it's just basically a formula where you're flipping some of these things around and changing some signs. So let's take this next one, for example. Let's find the inverse of the matrix 7, 4, -5, 3. So what we're going to do is start off, we need to find the determinant. Okay, the determinant of this matrix. Now remember, we find the determinant by multiplying on the diagonal and then subtracting. So we're going to basically be saying the determinant, in other words, remember the determinant of A, B, C, D is equal to AD minus BC. Okay, and I have actually put the symbol for the determinant. Okay, so we're going to say 7 times 3 minus -5 times -4, which gives us 21 minus 20. So that's 1. The determinant is 1. So if we follow the formula up above to find our inverse, we are going to take 1 over that determinant of 1. Now we want to switch the order of A and D, switch the positions. So we're going to have 3 in the upper left and 7 in the lower right. And we need to change the signs of the other entries. They do stay where they are, just the sign changes. So we've got 1 over 1 times 3, 4, 5, 7. And of course that just gives us the matrix of 3, 4, 5, 7. So that is the inverse. If you were to multiply this original matrix by the inverse, you would get an identity matrix for the result. Let's now find the inverse of 5, 2, 2, 1. So again, we want to find the determinant, which we find by taking 5 times 1 minus 2 times 2. So 5 times 1 is 5, minus 2 times 2, which is 4, gives us 1. So that's just by coincidence that it turned out to be 1 again. That's not necessarily a common thing. So our determinant is 1. So if we follow our formula, which is right up here above, we're going to take 1 over that determinant of 1. We switch the 1 and the 5. We change the signs on the 2's. And so really, since we're multiplying by 1, we just get that same matrix back. We say 1, -2, -2, 5, and that is the inverse. Okay? And what we're going to be doing in the next lesson is using these inverses to solve systems of equations. Thank you for joining me.